Synopsys is the leader in application security testing. With 84% of cyber attacks targeting the application layer, securing your software is more challenging than ever. Modern software development and deployment paradigms require security testing solutions that are automated, accurate, and integrate into your DevOps workflow. Synopsys enables DevSecOps with a portfolio of industry-leading tools, including Coverity, Black Duck, and Seeker, to help you build secure, high-quality software faster. Visit securityweekly.com/synopsys to learn more. Nearly every business today relies on mobile applications, yet the vast majority do not adequately secure them. Once downloaded, mobile apps escape your control outside the secure network perimeter, thus making them easy targets for hackers. Enter GuardSquare. From the makers of ProGuard, GuardSquare integrates transparently and seamlessly into the development process, adding multiple layers of protection to Android and iOS applications, and effectively hardening apps against both on-device and off-device attacks. Request a demo today of GuardSquare at securityweekly.com/GuardSquare. Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies. Protecting over 7,500 applications and 150 billion production requests per week, Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences' patented technology protects any application against any attack, with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at signalsciences.com/PSW.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. Attend RSA Conference 2020, February 24th through 28th, and join thousands of security professionals, forward-thinking innovators, and solution providers for 5 days of actionable learning, inspiring conversation, and breakthrough ideas. Register before January 24 and save $900 on a full conference pass. Save an extra $150 by going to securityweekly.com/RSAC2020 and using our code to register. So, John and Matt, this has been, as presaged last week unintentionally, Patch Tuesday has turned into Vuln Wednesday. In particular, the one vuln everyone's been talking about, Microsoft and their Crypto 32.
No, it's better than that. It's Patch Tuesday, yeah. Vuln Wednesday, and Exploit Thursday.
That's true. And then I guess Freak Out Friday when you realize that you didn't have good logging and monitoring for your systems. And what can we do for Saturday and Sunday?
I'd love that on a t-shirt.
That would be good. Yeah, let's get Paul on that right now. What can we do for this for our Security Weekly t-shirts? But what we are talking about here, for those of you who haven't been exposed to the world of Microsoft or the world of InfoSec news, is that uncharacteristically, NSA also came out and said, hey, we shared a pretty critical flaw in the way that crypto was being handled within one of the DLLs that are pervasive and fundamental to Windows. And of course, the initial speculation was that, this is going to be another parsing bug because historically ASN1 and X509, those have been very, very difficult to parse securely. There's always mistakes that can be made if we, as a throwback to our previous segment, talking about input validation. But no, in this case, essentially an attacker could create a custom curve for ECC, and the crypto API would basically say, this custom curve looks legit, and I'm not going to bother continuing to vet the rest of the certificate chain that falls, that is this sequence that falls behind this particular curve, and say, cool, this looks valid. And of course, in good, proper meme-worthiness proof of concept, a couple of people have been working on this, and one person put together, Salim Rashid, put together a proof of concept that was demonstrating how to rickroll different websites with what looked to be legitimate certificates. His examples were, I think, PayPal, GitHub. I think he even got NSA.gov in there. But essentially, that's a pretty consequential vulnerability when we start to talk about how it could be exploited in terms of phishing, setting up web applications that look to have legitimate certs, as well as signing binaries that could be perhaps ignored as legitimate by different types of anti-malware or antivirus systems.
Yeah, so the proof of concept code is completely over my head. The worst section I did in the entire CISSP exam was crypto. This is all beyond me, but it is a pretty interesting bug, though. The ability to get to make these certificates look valid, that could potentially allow you to step in and deliver malicious code or redirect to sites that look valid but are malicious. This is a pretty serious bug. That's why it's gotten a lot of hype last week.
ECC in general is so interesting in that since it first came onto my radar, probably late 90s, I think. It's always had so much potential. It looks so great. But, looking back at our last segment, it really comes down to the implementation, right? It seems like there's been quite a few issues with ECC implementations over the years. Really hard to get that guy right.
Yeah, and I think it's one of those things that even talking about the last segment, performance-wise, your keys can be smaller with ECC. So there's a lot of better storage characteristics you can get. There's a lot of CPU characteristics that are nicer for ECC over RSA. But even with ECC and the implementation, there was, I can't remember exactly when this was, but a few years ago when Acme and Let's Encrypt was coming out with the Acme protocol, they had a very similar problem with messing up some of the custom curve parameters within Acme protocol that led to basically untrusted certificates or untrustable certificates being trusted or mistrust within the chain. So it's one of those things that's kind of interesting. Here is a little bit of a history repeating itself because just because there's complexity, and as well as that sort of meta question, do we need this feature? Do we need these, how much, call it crypto agility, do we need, or custom curves do we need to support within these different implementations? Because it's a lot of it, or I should say, maybe I just characterize it as doing so increases our attack surface, leading to pretty consequential flaws in this particular case.
Yep. And I got to let a little bit of snark out and say big ups to whoever the PR person over is at the NSA who's trying to make this look like they're suddenly warm and fuzzy and a good bunch of folks.
I guess the only thing they missed, as it has been commonly pointed out, is that this hasn't been a branded vulnerability. So start your FOIA request engines just to see internally what they were discussing, to see what kind of branding they did want for this. But moving on from crypto, John, I think you highlighted there was some IoT device that was had a security problem and a software update that you had highlighted, I think, in this list.
Yeah, I thought this is fun. So one of the, I'm an aviation geek, and in one of my many hats, I have too many hats. There's a engine used on a Airbus A220s. That sometime last year, I guess there was a little bit of vibration. Sometimes we'll hear this, those of us who spend too much time on airliners, when these guys are taking off, sometimes a bit of a vibration in the engine, right? So they added a little bit of code in there to try and minimize this. It sure did minimize it. And in some cases, it was killing engines. And obviously, this is a really small thing. This didn't cause any accidents or things like that. This is on the scale of things, small, but still noticed. But what was interesting about this to me is that the Times did an article about the patch has been created, but since this is aviation and everything has to be tested left, right, up, down, it's going to be a month before that patch actually makes it out into production, so to speak. So, interesting that everything software has been eating the world for years, but now on your jet engines, been there for a while again, but it's sort of we don't hear about this type of thing very often, so I thought that's why I threw it in there. Not just a patch in ECC issues or things like that, but a very operational, very real world thing which you'd want to fix.
Yeah, what I thought was interesting here is that they're going to get approval to actually install a piece of software that will allow them to do updates quicker. That's one of the longer regulatory requirements here, is that they're planning to add something a little more permanent that would allow them to update these planes a little more in real time, which I thought was interesting. Because one of the things we covered on the first segment of Business Security Weekly at the beginning of the year was what I called the best and the worst of 2019, and Boeing was on my worst list. The way they handled the 737 MAX issue and all the things that happened with that after the fact and all the safety issues, to see this and kind of the positive light of what Airbus is trying to do to get ahead of this for the future is completely opposite of what Boeing was doing. So I think this is kudos to Airbus for trying to get software approved that makes it even easier to get software on these things to make them safer, faster.
And this is something interesting that we're seeing in a few different, I can't remember the examples, but I've seen it in a few places now in the last few months on the DevOps side of things, where highly regulated industries are hoping to get approval from their regulators, or their auditors, I should say, that both their processes and their baselines are secure enough and are thorough enough that they'll be able to start doing updates like this in a more frequent manner. Cross my fingers for them. I mean, I think the other examples I've seen are some stuff in GovCloud and things like that, where usually you'd have to, I know what it was. It was CISO for Air Force, I think. But basically they're going towards Kubernetes, and the intention is that the platform is secure and stable, that they can actually do code rollouts without having to reattest every time.
Yeah. That's where the industrial IoT side of this gets really interesting in a DevOps environment, right? If you have the right foundational elements in place, the ability to be nimble and quick to push code releases, as long as your regulators have approved the base platform. GE Digital was working on a lot of this kind of stuff back when we were talking to them, John, when we were at Layered Insight.
Yep.
Yeah, I think the only thing I can add to that is that's a great example of real world IoT, and not just like some home router with and how do we get it patched and how do we rotate its certificate. So I really loved that as an example. Changing gear, where there is more news from Chrome as well as other browser creators talking about what they're going to do with third-party cookie tracking, as in basically essentially dropping support for them, as well as basically blinding the user agent header. And turning the user agent header, rather than making it the very obvious, here is this specific build of Mozilla, the specific build of Safari or Edge or Chrome, for that matter, just turn it into a client hints header. And all of these are really designed from a threat modeling perspective. So I wanted to highlight this as a little bit less about what the browsers specifically are doing, and more of the how and why they're doing it, because a lot of reacting to essentially user tracking, data and privacy threats that they're looking at, they've done some threat modeling and figured out how can we change the architecture of our program in response to this. And basically looking at how that discussion has gone, I think, is kind of a different way of just replicating how you might go about threat modeling for your own application, in the spirit of, are you dealing with bots trying to scrape your website? There are different types of privacy attacks that can still happen, or just call them data manipulation attacks against your application. And these are two things that browsers in particular are doing for the whole web ecosystem.
Yeah, we've seen stuff like this in the past. There was, I think, wasn't Ivan working on some secure browsing thing at one time? I think if it wasn't him, it was somebody else. And then we've seen some solutions come out where they're isolating the browser. They don't even run them on your machine. They actually run them in the cloud, so they can isolate a bunch of data and protect them better. So we've definitely seen some interesting approaches to this before. It'd be nice to embed this into some of our core browsers, because I think then, it resolves some of these big issues around cookies and some of the other things that we've seen.
Yeah, I think also too one that change from user agent to client headers. I also like that from just the engineering perspective of rather than making assumptions about, oh, this is the browser, assumptions based on the user agent string. These are the assumptions I'm going to make about what the browser can do, its features. There's different engineering mindset to say, let's just do feature detection. If I need to spin up some service workers, do I actually have access to a service workers object or this other feature object? So it's the sort of an engineering principle of feature detection rather than just doing implied assumptions. So from that, it also just geeking out a little bit from that kind of design perspective and thought process. I like that approach better, and that's why I'm also from like a front end developer perspective, not really as worried about those particular changes at all either.
Yeah, the one thing that points out in here is I think this is a great piece. It says, and our experience working with standards community create alternatives and phase out Flash.
Yeah, I don't know. Yeah, I forgot to look to see what Adobe might have done for this Flash Tuesday, but I don't think there's ever not been a non-critical update for Flash or Flash. But speaking of, I guess, bad or software with historical problems, on the other end of the spectrum, Microsoft has released a tool, or they've actually just announced their tool to help find problems in specifically open source software, is how they've been describing and been using it. But they have Microsoft Application Inspector. It's a open source tool in C#, so it's for you .NET fans out there, but it's for basically inspecting different code bases. And their example that they were using it against was Python. So you can run it within your, you need a .NET environment, but it's not specific to just .NET. And essentially what they wanted to do is, yes, identify some programming weaknesses, things that might lead to SQL injection, cross-site scripting, those notorious duo that we've been talking about for a while today, but also just doing some basic, call it application inventory or feature inventory about the application, meaning, does this call into any crypto functions? Does this make a network request, an HTTP request? Does this open source library touch the file system? And just between crypto, file system, and HTTP, that can be pretty informative if you're starting to build a threat model or if you're taking a risk-based approach to saying, uh-oh, our development team, sure, they've been writing a few 100,000 lines of code, but they've been pulling in as dependencies a few million lines of code. How much of those million lines of code should we be worried about? And if we are actually going to take some time to go manually look at something, where should we start? And you don't want to start in alphabetical order or flipping a coin or some random walk, because you're just going to end up wasting your time. So this could be this, or any type of software analysis tool can be a way to put you on a good path for that type of investigation.
It does run in .NET Core, so I think that's actually a little more cross-platform support than just pure .NET environment, so that's good. I'll have to see if Paul can actually run this thing and see if it works.
Yeah,
I got plenty of Python code for him.
On the blog post, they do refer to it as cross-platform. I'm glad you found this one, Mike. I think you found it. I hadn't even heard of this. My biggest problem nowadays is keeping up with everything Microsoft comes out with. It looks really interesting. I think it's going to be my afternoon project here. The report. So if there's two pieces for those interested. There's a blog post announcing it, and then a GitHub repo. There's I think about 15, 20 releases on GitHub, so it's of some level of usability. But when I was looking through the README, while they had examples, they didn't have the output of those example commands, but the blog post does. So if you want to see what it looks like it can generate a HTML report. For those of us who are visual, that's a plus. So yeah, I'm looking forward to playing with it. It sounds interesting.
Yeah, I have my fingers crossed for this one in particular, because obviously a company like Microsoft can ostensibly is going to be able to maintain it for the foreseeable future, but also they're going to be, they just have a massive code base to run this against. And so hopefully with that improves a lot of what the accuracy can be as well as what they're looking for. So this one, the Microsoft Application Inspector, and if you want some extra credit, there's another tool that I've been looking at that's been around for a bit, Facebook's Infer, INFER. It's another, has some OCaml inside it because it has some Ancestry and some other tools they've been writing in OCaml to doing similar application type of analysis like this. So it's interesting to see what the large companies are doing and how much they are going to maintain and support these types of tools in the future versus them just being a one-off. We had a problem of scale. We came up with a tool to try to throw it at this problem of scale, and then sadly, hopefully they don't give up because it's just a bit too untractable. Hopefully they double down on tools like this, Microsoft, Facebook, the other big companies out there that have these types of resources and these types of problems. And because open sourcing it just makes it great for the whole community to benefit.
Yeah. I was talking to some folks up in Redmond last week, and I don't think this is anything NDA, but we've talked about this a few times. If you think about what they're doing, the GitHub acquisition, Azure DevOps, just a CI chain, all these security tools, they're sort of lining themselves up to have a pretty good AppSec story here. I think over 2020 is going to be interesting to watch. Hadn't heard about the Facebook one. Thanks for mentioning that. And what it reminds me of a little bit, for the Go folks out there, for us Gophers, it used to be Go Metafilter and it's now GoSec, which we use at Layered Insight and allowed us to pass due diligence code checks quite easily. We would do security scans at every build. It'd be interesting to see it. So to explain that really briefly why I mentioned it, Go Metafilter is a better name because what it's doing is it's collecting a bunch of different open source tools, running them against your code, correlating the results, and then giving them to you in a usable fashion. I'd love to see something similar for, Infer plus the application inspector plus a bunch of these other, like maybe something that could recognize what code you're using, automatically find the best tools of this particular week, and then give you the results back that could sort of, because half the game now is just keeping track of which tool should I be using here.
Yeah, and I think the other thing that I liked about this is that aspect of here are the features that are present within this particular code base rather than just that thumbs up, thumbs down that we didn't find anything. And just saying, okay, here's an empty report, we didn't find anything security-wise, that can give you the warm fuzzies, but that's not as information rich as we didn't find anything, but by the way, this is actually calling, this is relying on a pseudo-random number generator, or it's calling this particular encrypt decrypt functions or this particular crypto API, and maybe that is cause for further inspection. Or the other question of, wait, why does my left pad Node.js library need to make all these extra calls? And not that particular one did. I'm just calling that out as one of the notorious problems that have come in the past in software composition and dependency graphs. But yeah, I think there's a good information here that then can have some different decisions be made on top of it during that build process to say, hey, here's something that's present. Human, what should we do about this? And then human can say, in this case, we can skip it, move along, nothing to see here, or let's go ahead and dive in, find something wrong. Go ahead, you say something?
Yeah, I know you're working on a lead-in for your next topic there. Sorry. And I'm going to see if I can give you one. So, if I keep the thought in my head, I can't both kill you and lose it. What we were talking about here was, all these. How do we go about doing this? I know where I was going. And one of the things we've talked about a few times over the last few weeks is, when you have these languages that, suddenly go, well, I'm writing 10 lines of code, I'm going to bring in 100,000 more because you needed to be able to convert degrees to radius or something like this. It'd be sort of neat if someone had a utility which could go back through and actually recognize what you're actually using from those dependencies and then strip out the rest of the code so you don't end up with dead code in production. I don't know if there's any utilities like that out there. It's sort of a best practice type thing. If someone knows of that, hit us up on Twitter or any of the forums to contact us, YouTube comments. I'd be really curious to see what's out there in that type of space.
Yeah, I know there's a company called, is it Polysec or something like that, that actually attempts to do that, right? They try to take out and then create kind of your own custom set of libraries and builds, right? So that you can kind of strip that stuff out. There's a couple companies that are attempting to do aspects of this and creating kind of your own custom distributions that are streamlined down. But Paul's done the briefings. I haven't done them.
Yeah, I can't. The companies don't come to mind specifically, but the principle of it sounds like callback to Go is like, what does the static linking look like for Python or Ruby or JavaScript? Because that static linking basically says, oh, you're not using this function, it's not call, and it doesn't show up anywhere in your call graph. Cool, let's just get rid of it. You don't need it. And just like you said, that's a pretty compelling reason or positive thing for reducing attack surface. Because if you don't need it, just take it out. And I guess, and I know, John, you were struggling to give me that segue into the next one, but I guess all I can say is that we've been talking about source analysis tools, even just code scanning tools or vulnerability management tools more generally. But there's an article here that vulnerability management requires good people and patching skills. And really, this is, again, a common theme, so I don't know that we need to spend too much time on this one in particular. But just to point out that there's tons of ways of finding vulnerabilities and enumerating all the vulnerabilities in your code or in your environment or all the assets that are in your environment. But finding those problems and knowing that that is a problem isn't really the hard part. The hard part is actually patching. So even going back to the Patch Tuesday from Microsoft, I'm really curious what the exercises different organizations went through and how quickly they were able to say, these are all of the Windows systems we know about. These are all the Windows systems that are impacted, which in that case, I think the Venn diagram was pretty much a full circle. And this is how quickly we were able to patch them, because it's pretty much every single Windows system out there needed to be patched. But were you able to do that quickly? Were you able to also do them in steps, because you know that these particular systems are in an environment that are more exposed or higher risk? Or here is the way of going with a risk-based approach to patching this whole fleet of systems. And having that risk-based approach, you need people to reason that through. You need people to talk with. And really, that's just what this article, I think, is getting to. Security, work with your developers, because you don't just throw that Patch Tuesday to them and then go out for a happy hour that afternoon. You work with them to figure out how impacted are they, where should they start, how well can they and easily can they deploy patches.
So I can answer part of that question for you, because there are very few organizations that have applied those patches in the last 6 days. There are some, don't get me wrong, there are some very advanced organizations out there that patch that fast. But most people, it's a 30-day window. So we're day 6. My guess is not a lot of people have actually applied those patches.
That's right.
Sorry.
Well, and that's when one final article here, it was 10 best practices to embed security into DevOps. And really, it's just kind of, sure, they're practices, but they're basically 10 verbs about different activities that go on within application development and operations in general. And I guess I was trying to find the deploy and operate are the two that tie into what you were just saying there, Matt, about how many people are actually patched by now? Do they have that? Are they still within just the SLA? It could be that they were working with the security team that says, we've got 7 days or 30 days to patch this particular type of vuln. If they patch it on day 7, they're within SLA.
Right. Exactly right. The only thing I don't like about this article, secure is way too far down the list. So when you roll these down, okay, plan, I get it, but you should be doing some security planning in this discussion. Then you go to develop. Well, there's things you can do, like source code analysis during the development stage to secure your code. Then it says build. I can do checks at the build to make sure that certain security things are being addressed at the build. Then it's tests. I can come up with a bunch of unit tests to do a bunch of security use cases in my test scripts. And then it says secure. But to me, secure can be done 2-3 steps backwards. And so the thing I don't like about this article is secure is way down the path. And I think DevOps gives us the ability to actually do pieces of secure in some of these other phases before we get to deploy and operate, and they continue through there. So I think the structure of this does us a little disservice. I think we can do a better job of moving secure higher up or shifting left if you're doing this from left to right. That was my only beef with this article.
Yeah, and I actually agree with you, although I'm coming at it from a slightly different direction in the sense of I don't see secure showing up anywhere on that list. If you took secure out and you just said, here is a team that is going through these particular 9 steps now, but they're doing it with confidence, they're doing it with repeatability, they're doing it with a sense of speed in the sense that they can actually make code changes, those code changes can go through test cases, they can be vetted, then that security can emerge, and it can emerge exactly like you were saying, whether you're talking about it with source analysis, doing something in the build phase, specific security tests within the test phase, all the way into the end of operations, talking about how quickly can you patch the underlying systems to monitoring. So in effect, I like all of these, just take out that word secure, do all these other things, do them well, and bring in a security person who has good context and say, and go through that threat model exercise and then improve just what you're doing. And all those practices become, an emergent property of application security. It's just DevOps. It doesn't have to be DevSecOps in that sense.
Right. Because even in scale, adapt, security's in that role as well, right? I mean, security should be embedded in all those components. Because part of that adaptation is looking at the current threat landscape and making changes to my rules to protect the environment. That's an adapt structure. It doesn't just apply to your code. It also applies to security. So you're right, Mike. It's just security needs to be integrated across all these steps and not this 5th step in the middle where you don't wait until that step to deal with security. Otherwise, it's too late. We're right back where we started. With monolithic code, everything's done, and now you want to wrap security around it.
I don't understand what your problem is. I mean, it's right in the name, DevSecOps. First you develop, then you secure, then you put it into operation. That, for people, by the way, is a joke.
I was sorry. That was also basically the mic drop. I think that's just what we end. We've solved the problem. This was the last episode of Application Security Weekly ever because. 1, 2, 3 steps. You've heard it here from John Kinsella first.
Thank you and good night.
Thank you and good night. But not joking. Thank you, John. Thank you, Matt, for another great conversation. We talked about some fun encryption, input validation, protecting data, and went through some interesting news segments for this week. And please bring us some more IoT that is about real big systems rather than little devices that you can trip over in the corner of your room. Thanks for that. And thanks everyone for listening to the magic of how to do Dev, Sec, and then Ops this week. Thank you for joining us. We'll see you next week on Application Security Weekly.